Thanks, everyone, for taking the time and coming today. My name is Alex Grossman. I'm the Vice President of Media and Entertainment for Quantum. Some of you may or may not know Quantum. Quantum is a pretty well-recognized name in the media and entertainment business for a lot of years, but on the infrastructure side. So we've been the guys. Quantum, you probably know because if those of you have seen a lot of iPhones and Macs, people have had Quantum hard drives in the good old days, 25 years ago. The company's 35 years old, and they really started out in the idea of being able to do data storage. So Quantum built hard drives, they built tape drives. In fact, a lot of people know them from DLT days, you know, the old DEC product that Quantum really revolutionized the market with, and then being on the consortium from LTO tape. So that whole data protection side of the business. But along the way, Quantum merged with a company called ADIC, which was another big tape company, and they acquired this little product called StoreNext. And StoreNext was a file system that a lot of you probably have touched in one way or another. Early on in media, it was the file system, the go-to file system for SGI and Sun. So when you wanted to do collaborative workflows, that's what you basically did. And early on, you know, a lot of that was looked like a digital VCR in the early days. And then, of course, you know, I went to Apple in 2000, and I ran Apple's server and storage business. So I introduced product like Xserve, Xserve RAID, and XSAN. Those were all my products. And XSAN was an interesting one because at the time we were looking for a collaborative file system, something that we could share, and something that in the Apple world, because Final Cut was taking off so well, I mean, it was a pretty incredible growth, and we were looking for a way that we could make workflow just work. And I looked at every file system on the market. We looked at building our own from scratch. We had HFS Plus, but you really had to have something that was enterprise hardened, so to speak, years and years of work on it. And I chose to work with, at the time, ADIC, and we took StoreNext and the source code of StoreNext, ripped it apart, and built XSAN from it. And so that's really where the growth came from, where hundreds of thousands of seats of StoreNext came out. So over the years, after I left Apple, after about 8 years of Apple, I started a company called Active Storage. We went after the idea of integrating storage from the end to end for media. And I had worked with Quantum again, and I OEM StoreNext again, and said, how do we take this further? And so working with Quantum, I realized that they had this jewel, but it was going to have to really change the way workflow was done. And either StoreNext was going to become the basis for the infrastructure under the creative vision, or it wasn't. And so subsequently, I came to Quantum to be able to do that. So what I want to talk to you today about is an interesting concept that we have, and something that we've deployed at a lot of, well, we've deployed it in some major studios today, a lot of other firms where they're using it. And primarily, it's the idea of taking and eliminating the ad hoc growth that we're seeing from an infrastructure standpoint of how storage is managed from an end-to-end basis for most people doing what we used to call pre-production, production, and post-production, and then also how we add on delivery and archive, because let's face it, it's a round-trip process and workflow, the way workflow is done today. And the whole idea is that what I saw over the number of years, and I'm a storage guy, so although I've lived in LA most of my life, so of course I've written a few screenplays and been involved in much, you know, we can laugh about it, but it's true, a lot of production over the years. But the interesting thing about it is what I saw was this huge ad hoc growth in storage and the infrastructure around it. And what was happening is people were just bolting things on rather than building new infrastructures. And we saw this spit and baling wire type of approach. And really, when you have demanding deadlines, and you have, you know, creative people who just want to get it done and the demands are higher, how do you really make that work on a day-to-day basis? And a few years ago, we saw the integration of IT people moving into the creative process. And some cases it worked, and some cases it didn't, because the IT infrastructure is usually built for, you know, lots of what we call IOPS, or IOs per second, and not very low latency, which is what you need through a storage process if you're going to manage things like timecode. So the idea was, how do we go fix this? Well, in the meantime, and that was still in my active days, in the meantime, we started patenting things. I have a number of patents in storage and media workflows. And when I came to Quantum, they were starting something, I want to say it's a lot of the ideas we had, of working on something called StoreNext 5. And I was able to work with a team of about 100 engineers, and we were able to take these ideas and put them into somewhat of what we'll call our own standard for this, although we hope that people will adopt this. And we have a very large technology partner base, our ecosystem around this. And I think that that was something that made Apple very good in the early days. Final Cut had a great ecosystem around it. We tried to build a similar ecosystem. And so a lot of people have been able to buy into this because of a single API or a single programming interface to make it easier. So I want to talk about the technology around it, how others are using it, and how it ties into what we call the cloud today, because that's where it is. So let me start off with the first thing is, what's happening to workflows? Well, I think our last speaker caught this perfectly, is that workflows are completely changing. Everything's 100% digital. Everybody is using globally distributed teams. There's no doubt about that. File sizes and resolutions, they're not only larger, but they're just different. So there's no standard than standards. And the thing I love about standards, there's so many, choose one. The problem is, what are we going to do with that in the future? We know that, there's more ins, there's more outs. We know that when there's more ins and more outs and they're in different formats, there's more transcoding. Whenever there's more transcoding, there's more quality controls that need to be put in place. We think we want to automate all that, but can we automate all that? No. It's still the creative process, and creative people need to do it. So if you want to enable your creative vision, you have to have the tools around it, but the tools need to get out of the way. And that's really the key. And the problem is, you can take the best tools in the world, and we're using more and more tools every day, and put them on top of it. But if the infrastructure doesn't know how to handle it, it's just not going to work. So you have to have an intelligent infrastructure underneath all the tools to make them work. And that's what we're hoping to do and working with a number of people to put in place. So the other thing that's really changed are topologies and interconnects and how they happen. In the good old days, in my XSAN days, I could say, let's stand up a fiber channel SAN. It was pretty easy. Everybody's in the same room. Everybody's in the same facility. Hardest thing we had there was really just running the cable. And I can tell you there's many, many buildings where we ran fiber everywhere. But today, let's face it, not every operation is a real-time operation. So we're talking about IP, and also we're talking about the internet, the cloud. I look up. The cloud's really down, but I look up, right? It's the cloud. We all want to do that. And then, of course, with all this is the increased complexity that comes because people are asking you to do more with less, do more faster, do more in the same amount of time, and more importantly, deliver on every format there is. I went to CES as well. I was blown away. I talked to a number of I had a press pass. I talked to a number of the product managers that were there about all the UHT stuff that was coming out, and it was pretty incredible. I had just come from HPA, and all the high-end thoughts were there, and I got into CS and I found, wow, this is really lowest common denominator. Everybody's going to have a 4K display at their house, or many of them. And I really was blown away by how people are expecting this content to be there today. And we all know that content's not there today. But, I have Netflix. I watch House of Cards, so I'm 4K ready, right? Life is good. So, there's just this increase in complexity of what people are asking to do. And I think it's really driven by the market trends. So this is something that we all see, whether we like it or not, we're seeing it. So the pure post facilities are going away or consolidating. If you're a pure post facility, I feel bad, but let's face it, that's not what a pure post facility is anymore. Post isn't post anymore. It's just not post. There's a new breed of content producers and owners. We're in a facility today. I think this is a new breed of where we're seeing content come from. It's really incredible because people expect, the consumer is driving this in a way. They're expecting content to be available anywhere, anytime, on any device. And they expect the highest quality content on all those devices with no degradation in either performance or quality. It's always instant on. And by doing that, you have a lot of delivery challenges. And there's no doubt that it doesn't start at delivery, it starts at creation. And it's managed all the way throughout. That's also an interesting thing, is the remonetization issue of content having value over time and then increasing value over time. But where do you keep all that content? So, people are always looking at, there's many, Eric and I were talking about, there's many versions of what people call the cloud. The cloud's that's the catch-all phrase that people have. But I hear a lot of people saying, well, I'm just going to put this content up in the cloud because it'll be there forever. I don't have to worry about it again. Well, someone's still got to pay for it. You still have to manage it, and how safe and secure is it? So there's a lot of things to worry about. But remonetization of content is driving value, and people are trying to figure out, how do I get more money in my production? One of the ways to do it is to say, I'm going to do it in the highest quality so that I can remonetize it in the future. I can get more money. I see you smiling because I see these on RFPs come through all the time. Has to be 4K ready for future proofing. So it's an interesting thing. And then, of course, there's high resolution. So I was calling it 4K workflow for the longest time, and I got smacked in the head by the guys from Japan, and they said, 4K, 8K today, 16K tomorrow. So they really are thinking a lot about this. I mean, whether it's high frame rate, HDR, whatever it's going to be. The interesting thing is that older workflows that we have just don't fit that model anymore. They do, but the efficiency is just breaking down very, very rapidly. In fact, it's an interesting thing because if we take a look at some of those workflows that we built in the past, I lived through this, so I've been on the storage side of this in media in what we call desktop digital video in the good old days. I've been living through this since the mid-90s, and the interesting thing about it is every time that we thought it was getting easy, someone made it harder. So the transition from SD to HD, that was an interesting one because it took a long time all the way across the board. And from a storage perspective, it really strained us. We needed faster fiber, we needed faster disk, we needed more disk, we really had to make it work. And it was really hard to do. And in those days, it was mainly single stream. It was one camera. It was the idea that that transition could happen and our technology could catch up and we could do it. Well, fast forward to the transition from HD to high resolution or 4K, all of a sudden now it's multi-camera. It's many, many more streams. It's many more effects. It's better audio channels. There's just so much more there that we have to catch up to. So when we finally figured out how to do it with the lower cost infrastructure, guess what? Here comes high resolution and all that low cost infrastructure, it just doesn't work anymore. There's this little term called latency that you just can't get around in things that we have, and I'm not saying all topologies are the same, but things like a NAS interface, things like having IP, doesn't work for certain things anymore. Collision-based networks don't work anymore. The internet works great when it works great, but now we're buying all direct connect lines. So how many people do I talk to all the time that say, well, I had a T1 line. A T1 line's a joke today. I mean, 100K is just about getting there. Lighting up dark fiber. I was at a interesting facility. I can't talk about the facility, but they're outside the U.S. But this facility they're the second largest broadcaster in the world, and they lit up dark fiber around the whole city they're in. They have a 60-mile loop of dark fiber. It's about this big. If we did that in the U.S., the cost would be the cost of the studio. And they lit it up for about $25,000 a month, and they have pretty much unlimited bandwidth. We've been testing the latency there, and they're on microsecond latency between 6 facilities. But we're not going to get that right away in the US, and part of the reason is the telecoms own it all, but they argue about what they own. So when you go to buy it, it's always harder. So how does that work in the modern workflows we have? Well, we're going to take a look at my very rudimentary diagrams of workflow. So I take them and I look at them like this. I say that workflow is more than just moving content anymore. And the problem is, even though we talk about a nonlinear workflow, it's been a pretty linear process for the longest time. You ingest, you have work in process, there's more steps there than there's ever been. You deliver, you archive, and then you do some long-term off-site archive, hopefully. And not always. And what's ended up happening in this modern workflow is that it tends to look like this. It tends to look like a pool of storage that handles your ingest, your WIP, and your delivery. And you feel like, well, once I get it out of my site, I don't have to worry about it anymore. But you always do, because you're always touching it up, you're always remonetizing it, and that content stays there, and it stays with you for a long time. And this has had something that we used to call the growth of an ad hoc SAN, meaning that often what you do is you supplement the storage that you're using in work in process to hold what was really your nearline archive or content you need. Episodic TV production, especially the growth of what I consider wild episodic TV production, like reality TV, these 600 and 800 to 1 shoots. I mean, these shoot ratios, never throw it away. Where does it live? It all ends up in this online storage. It's kind of crazy. And the problem is that the archive ends up on tape. And often there's nothing wrong with tape. It's still the lowest cost media you can use. But the problem with it is it's not always easy to manage. And so what's happened is there's been a whole growth a crop of products that have grown from very simple DAMs in the old days to now what we call MAMs, which really isn't what they are. Now they're workflow automation tools for the most part. And to manage just what you do, because as a human being with this sheet of paper, you can't manage it all. And we can't all do it on the FileMaker Pro database that many studios use for many years. So it's just kind of crazy where that's gone. And the problem is that once it gets out somewhere, bringing it back, the latency of bringing it back can be, hours, days, weeks, months. And someone's got to manage that. Whether we like it or not, it's not an automated process. And so more often than not, you run into the point where your cost is getting to the point where now I have to get it out into a lower cost media so I don't have it when I need it. But the other problem that you have is that there's no window of time in your production today to actually copy it to tape or to move it somewhere else. In fact, what a lot of people have done is they've taken this approach and said, well, everything is coming to me digitally. If I'm a content owner, what I need to do is I need to protect my digital content. So the first thing I do is I archive it on ingest. So now I've even put more of a strain on my work and process. I've put more of a strain on my ingest. I've taken the time, and I've really, worked my tape significantly. But, you go, well, I don't know if I can archive on ingest. That might be too hard. So what I'm going to do is I'm going to put some other storage in there because that's safe, right? It's better to have it on RAID. RAID's really safe until things happen. So I'm going to keep it in my facility right next to the other one, and now I have nearline. And this is kind of your typical storage model where people are adding nearline, and now you have faster recovery, and you get it, and you got a big pool of storage. This tends to work. To me, it's the Band-Aid model of how you get around this. And let's face it, a lot of people are deploying this very effectively. And they're also growing their online, and they're replacing older with new because storage capacity keeps getting bigger. And bigger usually is cheaper per gigabyte. The problem that most people don't understand is in this bigger capacity, it gets a little risky too. One of the interesting things is that the true performance of a RAID system it's a system, so it's measured on a lot of things. But in the end, it's the performance of the head to media. So how fast can the head pull data off the media? And then, of course, what you want to do is you want to have more heads so that your limited head to media performance is less. But the more heads you have, well, then you have more drives. Because the other problem that's happened over the last few years is that drive manufacturers, which I still can't figure out how they make money on hard drives, but drive manufacturers have reduced the amount of components inside the hard drive. They've squeezed more data on each platter, as you probably know. So if you were to go back just a couple of years, even a 1 terabyte drive, let's go to a 500 gig drive. A 500 gig drive had probably 10 platters in it, and that meant 20 heads. So you had a head to media of 100 megabytes per second per head. That didn't mean you could get 20 times 100 megabytes per second because through the interface, you could only get one head to media. But you had a lot of heads to pull from, so you didn't have to move the heads across the platters. You could just do what's called an elevator seek up and down the heads. So you could pretty much build intelligence in what's called your RAID controller to be able to do that. Well, go today, and has anybody using 6 terabyte drives today or 8s? I can tell you this facility uses more than just about anybody in the world, but a 6 terabyte drive will have, say, 4 platters. Some of them have more, but most of them have 4 platters and 4 heads. So now the problem is there's much more density in that disk, but the problem is you're moving those heads a lot more often, and your head to media is still 100 to 150 megabytes a second. So even though on my capacity that I need, let's say, I'm just going to use round terms here, let's say it's 60 terabytes of capacity, how many drives is that? That's 10 drives. But at 100 megs a second times 10, I got a gigabyte a second. But my workflows could easily exceed, your typical post-production workflow is 6 to 8 gigabytes a second. So now I got to buy a lot more capacity than I need. I feel really good about this. But the other problem about that is now your failure rate goes up the more drives you have. And when a bigger drive fails, the rebuild times are pretty astronomical. In fact, a 6 terabyte drive, even with some caching rebuild, which is scary, do those things called cosmic rays and things that can interrupt things, and there's no way to stop them, except for maybe Iron Man or Superman or someone. But the bottom line is that it can take 2-3 days to rebuild a 6 terabyte drive, even if you're smart about it. And so there's a lot of technologies around that eliminate that, but they don't always help the latency. So in an online, the best thing you can do is, well, I guess go to flash. but that's still 4 times the cost of doing it in hard drive. So not a lot of people are doing that yet. But the key would be, what if I could shrink the amount of online I need by being able to make my nearline smarter and faster? Well, you probably can't do that. Well, maybe you can't. So that's what I want to talk about. So this is a concept that we had a couple years ago. We said what we're going to do is we're going to enable every one of our technology partners to be able to talk to every single device that we have through a single common API, so that we can do data movement between what they used to call tiers of storage, stages of the workflow, between any device in an automated fashion by allowing either the workflow management tool or the MAM to do it. Sounds great, right? Sounds fantastic, and it allows you to do that. But today, the workflows are really complex. You've got all kinds of things going on. You've got different types of clients. You've got preview clients on IP. You've got hardwired clients on fiber channel. You know, you have switches. You have routers involved. You've got transcode farms and render farms, and some of those render farms may not be local. They may be in the cloud. It's very possible. And you've got preview stations. You've got people working. You've got QA. You've got stuff coming in and going out constantly. So I did a very simple drawing here, but I want to look at the other way of doing this. And that is, if you break the operations that people do today into real-time and non-real-time. Now, I would say when you go back to what I had on the initial drawing of workflow, early on, all operations were real-time. They really were. I mean, you ingest it, you edit it, you delivered. You know, if we call it tape in and tape out, with bookending a workflow where the work and process was done, it pretty much all had to be done in a linear fashion. If you collaborated, all you did was put it into a bunch of parallel areas. But today, it's not true. Some of your stuff is real-time and it's non-real-time. And I took a stab at looking at what I call extended online. So what do I call it that? It's kind of a cool term. But it's not nearline. It's really doing what you do in an online fashion, but adding some value to it. And I'll explain that in a second. So the idea here is that you have operations that are real-time, and we could argue what they are, but ultimately these are the ones that I tend to look at real-time. Your edit, your color correction, all your effects, most of your audio sweetening. You could say ingest could be real-time or not, depending on who, it's usually faster in real-time coming in, but where you're acquiring it from. If you own the ingest and you have single ingest coming in, it doesn't have to be real time. But if you're going to have multiple ingests coming in that are going to have to use a non-real-time operation like a transcode, it's real time. And then, of course, finishing. So the non-real-time operations are the ones that are really pulling down the performance of the entire workflow. Because what happens is, while your performance of what you do, let's say streaming content, so let's say you're doing an editing process, and an editing process today no longer means a single stream, from a single camera. It no longer means a single editor. It also doesn't mean that you're scrubbing forward in the timeline. You're scrubbing backwards in the timeline. You're moving around. You're using a lot of sources. And so at that point, you're causing those poor hard drives and those poor head-to-media to move all around. So the data is no longer aligned. So I can write data, and I have a couple patents on how to write data for media and how you write the data onto the hard drives. And so I have a little bit of experience in this. And you want to line everything up. You don't want to fragment things. You want to line everything up. So as I read in a contiguous manner. And we think of streaming as a contiguous amount of data coming off the drive. It doesn't really work like that, though. And the honest sense of the world, streaming means I'm putting it on a bunch of different drives and I have to move those, and I don't know where the other data that intersects them is. Now, if I had thousands of hard drives, maybe hundreds of thousands of hard drives in, let's say, under 100 terabytes, I could put the data so it would all align perfectly. That's like the engineer's dream. Fortunately, we don't live in an engineer's world. We live in a creative production world where I want it now. And given that that's the case, I have to think about things like transcoding, where maybe my stream of video might be in the gigabytes or in the terabytes. My transcoding is going to spit the data out in 4K files. And I'm going to build thousands, tens, hundreds of thousands of those, depending on what process I'm doing. Whether I'm doing a transcode process or a QA process, and how many formats I'm spitting those into. And I can tell you right now, the worst thing that systems like, especially Fiber Channel, the worst thing Fiber Channel likes is having small files and big files together. So you say, well, I'm going to put those small files on IP. That's what I do. I move my transcoders to IP. But the problem with that now is all of a sudden now, when you're going to IP, I have to cache the stuff going to the transcoder, then put it out there. But when I bring it back, I can't cache it. I have to write it. So it really hurts the performance. So what you really want to do is you want to take those operations and separate them. And that's what I've kind of shown here. But you can't separate them if you're doing it in a nearline fashion where your smarts that control all of your workflow, if your smarts are centralized in a single area, you can't do it. So what you have to do is you have to have smarts that say, I'm going to automatically move things to the best stage of the workflow I can. So let me kind of explain the way it works a little bit. So extended online, it streamlines your workflow. What it does is it essentially takes all the storage for your work in process, your archive, and your long-term, if you want to, your long-term off-site content, and it puts it into, I'll use this term media browser. It's kind of a popular one that we Apple guys like to use, right? All your media is there in a single place. You know, we have that whether you're using Premiere, whether you're using Final Cut, even in Media Composer. You have this browser concept that all my clips, all my pieces are there. Well, when you do this, you put them all in one place and you bookend your workflow with ingest and delivery. So you achieve less complexity, kind of greater efficiency, and it's really good for high-resolution content. So this is where it really gets driven, and then I'll explain how it actually works. So you're actually replacing nearline. So nearline became a big additional pool of storage. Doesn't do a lot for you. It's a little more expensive per terabyte, or a little less expensive per terabyte with nearline, but there's not a lot of value to it. All it's done is it's taken the pressure off a little bit off your work in process or your online storage. You've just basically kicked the can down the road. You've put a little bit of chewing gum on there or some baling wire. And eventually, the biggest problem with everything that's online, for the most part, or the way it's been today, is that online has to get migrated. So whether you know this or not, hard drives wear out. And usually their life, depending on what the duty cycle is 3 to 5 years. And in a high duty cycle environment like online storage for media, you'll usually see 3-year life and you'll start to see problems. And the problem is the drives just don't die. They get sick and elderly. And, you know, they break a hip, you know, and something like that happens and they're not up and around. Things happen when they get old. And they start to fail. And the problem is when they fail in a cascading manner, that's when you lose all your content. And the problem is not that you don't have it archived somewhere, because you all are smart and do that, but, and at least 3 copies of it just to be safe, but the problem is you have downtime, and downtime's always bad. So you can actually hurt the performance of a high-resolution workflow by using online. So when you got to prepare for high-resolution workflows, you're going to see it's different. There's so many more steps, you know, more QA. There's way more transcoding going on, and there's more number of in and outs. So when you look at extended online, you say, how can that make it more efficient? So here's what it actually does. So when you look at extended online, the way we implement it is we have an object storage. We have an object storage product that we call Lattice, and it's actually a private cloud product. And we do extend our private cloud into the cloud, and we do extend our workflows into public cloud, and I'll talk more about that. But the idea of private cloud in this case gives you the capability of doing what you do with the highest level of security. So, I mean, content is king, and it's your ownership. And whether you're delivering a service or you own that content, you're responsible for securing that content, regardless of, you know, even if you aren't under MPAA or anything like that. But the idea of extended online is that we can take and seamlessly extend the storage and the operations in a workflow. And what's different about this is that if you think about the nearline storage, it's an interface in and interface out. It's a single interface. Your work in process, to a certain extent, is a single interface in and a single interface out. So if I look at it from a StoreNext model, and this would be the same as an Avid model, and it would be the same as just about any other file system that's out there, and there's really not a lot if you think about it. These file systems all have a single in and out with a control called metadata. And it's not the metadata you're thinking of that describes the content. It's the metadata that describes who can use the content and where it lives. And so every time you have to do a call into the storage to get the metadata to figure out where the content is, you have to slow down your workflow and add latency because you have to make it think. No matter how fast we make it, no matter how fast CPUs get, you still have to have a single brain doing that. Or do you? Well, the standard model says you do. With extended online, what we do is we tie those together so you have two separate workflows. And we give control to the object storage, and we say to the object storage, you know what? Your MAM, or your workflow management tool, can move content and copy content between your online and your object storage or your extended online with no degradation in performance to the rest of your workflow. And then once that content moves over to object storage, you can act on it in many different ways. So you can get it back to your users by pulling it back to online, or you can do things like add, quality control, transcoding, delivery, anything on it via IP. And you can run that fiber channel and an IP with no performance degradation on either. And you can also go out to public cloud or out to remote users through HTTP REST, which is the standard interface of the internet, or what we call S3 as well, which is the non-standard interface, but it became standard because of, or it's the pseudo-standard, I should say, because of Amazon, right? Everybody knows what S3 is. And so what Extended Online does is it gives you the ability to manage all that without hurting the performance of your system and allows you to put your content in a much more resilient manner. So if you think about this, RAID is pretty safe as long as it's new, as long as it's well protected, and as long as you're willing to manage it and monitor it. The worst thing in a RAID system is you lose a hard drive, you got to worry if you lose another one, even a RAID 6. And your performance is degraded to a certain extent as you start to see hard drives fail and other things that can happen. The nice thing about what we've done with Lattice Object Storage is it's true object storage. So from a protection standpoint, if you think about this, in a RAID 6, you have 2 parity drives for every certain number of hard drives. And the rule is usually 2 out of 10, so 8 and 2. And the reason that this is the case is that if you look at, forget about MTBF and MTBF lies and everything else, hard drives are supposed to last 1 billion years or whatever it is. Dinosaurs can, use them or whatever. I don't know how they tested that. But for the most part, you can't look at it that way. You have to look at it and say, in a life cycle, the more drives you have, the more chance they're going to fail. 1 in 11 is usually the number. So you knock it down to 1 in 10. So as long as you don't have a batch problem or cascading drive failures over age, you're pretty safe in that. But realistically, that can't be your only copy. So you want to make a mirror of that, which a lot of people do. We do that all the time, replica SANs. And then you want to get it off the tape. But when I do that, as I make a mirror, I kill the performance of my RAID. So now my users have to have an oversubscription because I can't get as many users there. And then as I lay it out the tape is slow, and tape feels a lot like IP. It's taking little pieces at a time, so I'm hurting the performance again. So I have to oversubscribe and buy way more online storage than I need. Or what I can do is I can put it into object storage, where what it is you look at the resiliency of object storage, it's many times better than RAID. In fact, ours is one of the few that you can actually dial it up and dial it down depending on when you want it, and you can do that in automated fashion. So when you first do a job and you want to bring it over there and have it very secure, you can make it 4 times as secure as RAID. And the beauty is it's self-healing and self-protecting, and you never have to migrate the data off it because it's self-migrating. Well, I won't say never because technologies will change, but let's say over the next 100 years, you're going to be pretty safe with the technologies we have between flash and disk to do that. And I can still get the performance that I get both on IP, REST for the cloud, and directly on fiber channel. And we did one more thing with this because we felt that we couldn't take people using public cloud away because you still need public cloud. And there's certain reasons that you're going to have to get to that. So we put an AWS connector that we call QCloud Archive into StoreNext. So there's no bridges, gateways, translators, nothing that's going to cause you to have to do a QA event going in and out of the cloud. You simply tag it into StoreNext, set a policy, and it'll just push it up and pull it back from AWS, either off your object storage or direct. So really, getting this unlimited scalability and self-healing with no migration is a big thing. And to me, we're one of the few pioneers to do this simply because we own the file system and we can control how all the other vendors that deliver pieces like media asset managers, for instance, I'll give you, for instance, working with media asset managers, we're working with NLEs, we're working with quality assurance companies, we're working with all these different companies, including many delivery companies, to build our standard, our API underneath it. And so it's a great way to do it. Do I think that people should adopt extended online from us and from others? Absolutely. This technology is safer. It's less cost than baling wire and chewing gum in the end. And it allows you to build an infrastructure where you can reduce that amount of online storage and also help to reduce the reliance on being able to make sure that you get multiple copies of archive right away. So that's about it for me. Any questions? Sure. Mike?
All of those are the same organization. Are you able to handle scenarios where the various components of that ecosystem are actually, on the work in progress side, that's maybe 15 to 20 vendors, each with their own IP stacks and their own fiber stacks and anything else, their own locations, their own access controls, as well as archive, which is generally a content owner, which very well might be a totally separate P&L and a totally separate use case. How do you stitch all of those environments and all those domains and all those namespaces together in a seamless manner to get that data to the person who needs it?
Yeah, absolutely.
And access control over the top of all
And that's
that.
been the challenge for all of us for the longest time.
Yeah.
And I love to say that's really easy, but it is doable.
Mm-hmm.
So there's a couple things that you have to be able to do to make that work. So to make it work seamlessly, if all those environments use Xsan or StoreNext, it's very simple. It's seamless across the board. When we have this mix of Quantel and Avid and all these others, we have to do export and import between them. But we do have technology partners, and there's a whole list that we can do to be able to do that. We've built those scenarios to be able to get there. So it isn't as seamless today until there's standards put in place to be able to do that. But our APIs allow you to go in and out very easily.
Gotcha. So what you're saying is that the StoreNext control. If I'm one facility and I have a StoreNext controller and I have object storage and online storage and everything in between, and there's another facility that has data, and in between there's Amazon S3 or whatever, I can give pieces of authority into your environment and we can trade namespaces back and forth.
Absolutely. And that's the way it actually has to be done. And there's an interesting technology that we've been working with for a couple of years now called Object ID Export, which allows us to even people, if we only had one extended online at a single facility and you have no StoreNext, you have nothing in the facility, but you have access to a browser, we can export the IDs to you, send them, and the MAM can manage this. So there's a few that we're working with. I won't mention the names, but there's a few that we're working with that manage these IDs. We export the IDs to them, and they manage a global namespace across them. The pseudo global namespace, because global namespace kind of is one of these terms like the cloud everybody throws around, means everything is in sync. Everything's not in sync. There's still a time delay, but that's exactly the way we do it. And so we can allow it to do that. The nice thing about doing it privately and being able to use object IDs and all this is you can have levels of encryption and levels of protection across it. And so we can push through Amazon as well. But of course, it's encrypted when it's up there and it's encrypted going down. It's not encrypted on either side of your end. And anyone you give access to on the outside is the issue.
And in terms of the tiering and the caching, pulling things up to the online level, is that controlled by policy based on access requests, or can it actually be done out of band and be provided by, like, can I give data gravity, basically say, I anticipate this is going to be needed,
Absolutely.
not that it has been requested?
Yeah, either or.
Gotcha.
Either or. And in fact, the nice thing is there's a web services API, which is basically like a REST interface that we've given to it. So it allows it to be completely dynamic. In fact, you can change those policies dynamically on the fly in the object storage, and you can change the durability settings dynamically on the fly. So if, let's say, for instance, you have something that was canceled and you're not going to use it, you can dump it. Or you can give it less reliability. Or if you don't own it, someone says, I want to, you're going to own this content, you give it back to the content owner and your contract's up, boom, you can just delete it really quickly. Yeah, Phil.
The ability to encapsulate metadata with the user metadata with the essence. To what extent are you exploiting that or giving the users hooks to configure that. I presume we're talking about Storage Manager.
Yeah.
This is all supervised by Storage Manager?
Yeah, Storage Manager is a tool that Quantum has as part of StoreNext. And what we've done is we've taken, I don't want to say the best of Storage Manager, that would sound bad, but we've taken pieces of Storage Manager that are the most applicable to be used normally, and we've built it into StoreNext 5. So we have a new version of StoreNext 5 that has many of the Storage Manager calls. And then what we've done is we've taken Storage Manager and kind of upscaled that a little bit to be able to manage these pieces, and we're laying these pieces back in. So we've been working with a number, we built a web services API to do exactly what you're talking about, and we've been working with a number of media asset managers to manage this. Because one of the problems is, today, if we gave you a UI that you managed it yourself, it would be a single point of management, and it would have no database behind it. So we would have to build that database. So we don't want to be in the asset management business. We want to enable asset managers to do this. So exactly what you're talking about, one of the nice things about putting everything in IDs and being managed, really quick on the object storage piece, the beauty of object storage, and especially the S3 interface and some other things, is that you never append a file. You just build a new object. So the file always remains. So it feels like instant version control across the board. And you can assign metadata across multiple versions.
But so beyond the metadata, how granular is the control? Because in our business, a lot of the image files that we work with are image sequences, so they are file per frame, and writing a frame per object can incur a lot of overhead, and it depends on what sort of storage subsystem you're using.
Right.
So are you giving the user hooks into how sequences are encoded, or whether you're encoding multiple images into object?
I would love you to come talk to our engineers, because they're working on that right now. So that is one of the things that we haven't released yet, but it is something that we're working on very carefully. Because one of the problems with doing the sequences again is who controls that, and how broad do you want to go? And so I'll hit you up later, because it's
enormous possibilities.
It's enormous possibilities, exactly. And we would love to have a standard, which I know certain people are working on, to be able to help us do that, because we've been a little reluctant to put in some of these advanced features into our software. We've been doing it in some custom engineering, just because if we do and the standard changes, then we'll orphan these. So.
Yeah, but conversely, you have the possibility of building proprietary roadmaps.
Absolutely.
Within that structure.
Yeah, and that's exactly why. I mean, the taxonomies are different. Yeah, everybody you talk to, and it depends on who has implemented it. And what we're seeing is somewhat of a polarization out there. We see people who want this to be completely dumb, and and unfortunately, when they want it to be completely done, they're in the manual process world. And then we see other people who want everything to be automated and to be done, and the automation is actually better in a lot of ways, because it allows us to tie things together to do the things that you want to do and tie them together.
There's so much that object storage has to offer that I think it would be silly to make that a dumb passive system.
Absolutely. And one of the things I just mentioned, one more thing on that, is that what we've done is we've been able to build multiple, I don't like to call them gateways, we really call them on-ramps into the object storage. So, if you can use the same technology you use going the object storage that you go to the cloud with, so public and private cloud look the same, the person writing the software only has to write one interface to do that. And so with object storage today, the way we've implemented it, you can do HTTP REST, you can do NFS CIFS, SMB, and you can do fiber channel across multiple interfaces, including InfiniBand, and you can talk across all of them simultaneously at the same time, and you can use tools like StoreNext to direct where they go. So what we used to call affinities in the good old days of StoreNext, affinities allow you to steer based on the file type where the file will go and how the file will be written. And we've taken the affinity model and we've made it much more fine-grained to now where you can say when a file hits a certain, it's always been age, right? HSM or file movement has always been on age. Well, now it's on file type and usage of files. So this way you get much more fine-grained of where it's going to go. For instance, if you had multiple facilities and one of your facilities was working on one project, yet you didn't need those files yet, we could steer the files there so that they're on-premise on time, because one of the problems with the cloud and with having things in a private cloud environment is that you have to think about how much does it cost to move files in low-cost storage across the internet. So we're able to do that as well. Okay. Thank you very much.